See, my memory's going from all these movies. We saw the movie last night, Wonder. It's like it's like my wife wanted to see it too. It's like about this kid who has like a facial deformity, and he's like just starting junior high or something. So he's going to school for the first time, and all the other kids make fun of him, that kind of stuff. And it was a good movie. Thought it was well done. Close this. So was this what was our homework? We're sorting them on their names? Oh, that's right. So using a double. But we had to have it display on the screen because right now we're outputting, right? So do we have to do it with text fields? Did I say you had to do with text fields or no? All right, so just sort it. All right, so last time we looked at comparators, right? So we went into we were looking at inheritance and then patience, that's it. So last time we looked at the compare to function, right? Compare to function returns something less than 0 if the calling element comes before the guy that you passed in. Returns 0 if they're the same. Returns something greater than 0 if it comes after. And we had a interface called comparable. What is an interface? Okay, it's not a class. It's like a class, similar to a class. You said it's an API. What does that mean? It's not quite an API because APIs imply it's applied implementation, but it's pretty similar to an API. What does it mean for something to be an interface? Yeah, so like the comparable interface required that we create a compare to function, right? So if we say we want to participate in the world of comparables, okay, we want to implement the comparable interface, we had to write our own version of the compare to method that returned the proper type of information, because anything that was going to use us as a comparable was going to rely on that function being there. So it was our responsibility to ensure that that function was there. All right, so last time we wrote for our class person, or toString. So we had our array called persons that we filled up with. Now we filled it up with some patience. So I undid what we had done in class last time, right? Last time we had this guy and he was implementing comparable on person. All right, so now this guy is screaming at me. He says, this guy must either be declared abstract, which we haven't talked about yet, or must implement a method called compare to from comparable. So it says we've implied that we want to play the game of comparables. We've implemented this interface. So now it makes us, as Charlie pointed out, follow some rules. So the rule in this case is we have to have a method called compare to that takes a person P as a parameter, and this guy has to return a number. Less than 0, greater than 0, or equal to 0. All right, so notice that this guy is now happy. This guy's now happy. So if inside here we said I think we wrote it shorthand last time, so we said return age minus p.age. So if our age is greater than P dot age, so let's say we're 15 and we're comparing ourselves to somebody who's 13, we should come after them if we're sorting ascending, right? So 15 minus 13 would be 2, which is a number greater than 0. If we are younger than them, let's say we're 13, they're 15, 13 minus 15 would be negative 2. We should come before them. We're younger than they are, so it's going to return a value less than 0. If we're the same age, we're both 13. 13 minus 13 is 0. So it would return a 0 because we're the same. So this guy would just return our age. So this is this dot age minus the age of the dude we passed in. And that would give us the proper values, either less than, greater than, or equal to 0 for comparing us on ages. Make sense? So that's if we wanted persons to be comparable. But what we did last class is we introduced this idea of inheritance. Well, we had previously introduced it, but we implemented it ourselves. So we said that we have this new classification. We have a class called patient. And a patient is a person. So a patient has everything that a person has. So that means that they have a first name, they have a last name, they have an age, they have a gender. All patients have all those things. Okay? But they also bring one more thing into the fold. A patient has a balance. They might owe the doctor something, right? Okay, so they have a balance. So when we create a patient, it's going to take in the first name, the last name, the age, the gender, as well as the balance. And the very first thing we do is this. What's happening here? What's that line do? Oh, 1 second, sorry. I never started the recording. I thought maybe I did start the recording. Oh, well, we're good. It didn't show up there. It pushed too much off. Sorry about that. All right.
So it calls the first object the parent object, the constructor.
Yeah, but it calls this calls the constructor of the parent object. So the parent of this guy is person. So this will call the constructor of person, which is this dude right here, which takes in a first name, a last name, an age, and a gender. And that happens to be the exact information I'm passing in here. First name, last name, age, and gender. All right. And I have a comment next to this that says, if you intend on letting your parent's constructor do some of the work, it has to show up first. Why is that? Why does this have to be the first line of the patient constructor? It's a rule in Java. Why do you think that is?
That's going to have constructor too.
Because you extend into that one, you have to call.
So we can think of it almost like a chicken or the egg type problem. So let's say that we're building a house, okay? And it's a little bit of a loose example because it doesn't really support the inheritance aspect, but we can support the before or after part of this. So we need somebody to come in and install the drywall before we can have somebody paint, right? So maybe this guy takes care of installing the drywall, doing the base setup, bringing us up to, whatever it means to be just a person. And then after that, so everything's set up for us to be a person. Then after that, we differentiate ourselves from persons, possibly making changes to what was already set. So one thing you don't want to do is you don't want to be able to say this. You don't want to say this dot first name is equal to nobody. And then arbitrarily call your parent's constructor, which we happen to know changes first name. Because now we undid what we purposely did here. Call the super must be the first statement in the constructor body. Okay, so they're saying if you want to rely on your parent to do any of your heavy lifting, do that first. Then differentiate yourselves from that in case your parent did any damage. So if after this we want to change our first name to nobody, let's just change it to LOL, quicker to type. That's okay. We've accepted the fact that, hey, this constructor might have set the first name, but now we're going to adjust that. We'll make the changes that differentiate ourselves from a default person. Yeah.
When you're calling first name, why isn't this not super?
Because since we inherited, since our parent is person, all of these guys are delivered to us because we made them protected last time. So when they're private, they're only accessible inside the person class. By making them protected, it now makes them available to either the class itself or children of this class. So when we're in patient, those variables are kind of invisibly up here. That we have them. They came along with us. So this dot first name is the same as super dot first name. In fact, actually, it's an interesting question. Can I say super dot first name? I think I can. Yeah. They're synonyms with each other. Because super dot, well, actually, there's a good reason why. So this is a good question. So when I say super dot first name versus this dot first name, what's actually happening here? And it deals with how variables are resolved and scope. Variables always resolve to their what? Most local definition, right? So all variables resolve to their most local definition. So when we say this dot first name, the very first thing we're going to do is we're going to look here and say, do I have a variable up here called first name? I don't see anything. So then it's going to say, well, where else do I have to look? Well, the next place to look is in your parent, which is person. And we happen to have an instance of our parent called super. So when we try to access our variable called first name, it automatically passes that through to super.firstname because that's who our parent is. The instance of our parent might have that guy. Now, if we don't find it there, let's say we're looking for this dot something. Okay, we're looking for a variable called this dot something. What places does it check to see if it can find a variable called this dot something? Okay. Well, it checks three places, right? So it checks patient. Where else? Person and object. All the way up the hierarchy, right? A person is an object. So there's an invisible extends object here. So that's the top of the, we can't go any higher. That's the end. So we'll check patient, then we'll check person, then we'll check object, then we screen. So that's what happened right here. It said, cannot resolve symbol something. I checked locally in patient, I checked more globally in person, and I checked even more globally in object. Couldn't find it anywhere, therefore it's an error. Make sense? That's scoping rules and how variables are resolved. Oh, deleted a little too much there. All right, so here's our patient extends person. A patient differentiates themselves from person by having a balance. So the constructor here is going to take in all those pieces of information. We're going to leverage our parent, who is person, by calling their constructor using this special syntax right here. And this has to happen first in our constructor. If we intend to leverage our parent's constructor, which we don't have to do, we can choose to do all the setup ourselves. We can say, if we just want to cheat, we'll just come in here, we'll steal all those lines, come in here, we'll just comment that guy out, and just say, look, we'll do the work ourselves. Those are functionally equivalent. Oh, yeah, so functionally equivalent, yes. But here's the problem. Just like we've seen before, there is an invisible line up here. That. If you don't specifically call your parent's constructor, it's going to attempt to call the no argument constructor of your parent, because really what's here is it's saying super is equal to that. It has to define that variable super. All this is happening invisibly to us because it always happens this way when we use inheritance, when we extend a class. So Java's model is we're not going to make you type stuff that you would always type the exact same way. And previously in class, I've referenced like Objective-C, which shows us a lot of the details, which I actually prefer from a teaching perspective, but Objective-C is kind of scary otherwise. So Java being a more modern language than like an Objective-C or a C or a C++, shows us less of the detail, so we're not exactly seeing what's happening under the hood as much, but it's still happening. Okay, Java just sort of hides it from us. So we have this little thing here. So if you want this guy to not scream, what we would do is we would come here into person, and we'll undo this in a second. But I'm going to create a second constructor here in person. Public person takes no parameters and does nothing. So this is a default no argument constructor. Like that. So now in patient, this guy's happy again because now he's able to make that initial call to the no argument constructor. Okay. Now what's interesting about that is if I delete this guy, the error is going to be back, right? So come back here. It's now screaming again saying there's no default constructor in person. So I'm going to come back into person. I'm going to get rid of that constructor. So now I have no constructors in here. This guy's happy again. Why? What did that just tell you? I wrote 0 constructors inside of person. Well, so I wrote 0 constructors in here. We know that patient, the very first line in here, if I don't write something otherwise, we'll make a call to my parent's constructor. That line was invisible. Still okay with it. Do I have a constructor in here that takes no parameters? We don't see one, do we? We didn't write it. Although, say this again?
In main activity, are you calling person constructors?
No, it doesn't matter. That's unrelated. Because if we were to call, if we're calling our patient constructor, we're calling patient constructor.
Okay.
But that doesn't matter in this case. It's not related. So if I'm in patient and I extend person, this guy right here is calling my constructor in person, correct? Go ahead.
Person's what's called the super from object. Like super blank one from.
That's a true statement, but not what's going on here. But that is a true statement because why would person be any different than patient? It's going to call its parents super constructor. So the reality is that is happening here after the answer to the question that I'm asking. This is working, right? I'm able to call a no argument constructor my parent. Who is my parent here? Person. That means that as far as Java is concerned, there is a constructor in here that takes no parameters. As far as Java is concerned, that's there. If I paste my real constructor back in, and I go back in here, Java is no longer convinced. Why is that? What must Java do if you do not provide a constructor for a class? No, that's kind of what he was saying. Yeah, it gives us a default one. If we don't write one ourselves, which shouldn't happen very often. You should usually create a constructor. But if you happen to be making an object that literally requires no initialization, you would choose not to write a constructor. And what will happen is Java will create an invisible constructor that takes no parameters and does nothing except, as you pointed out, calls objects constructor. It has to do that because a person is an object and a patient is a person. Therefore, a patient is also an object. So it's doing all those things behind the scenes, but it can't accomplish that task unless Java stepped in and said, okay, you didn't write a constructor here, so I'm going to give you one. Make sense? So Java will provide a no argument constructor if one is absent, if any constructor is absent. Now, the second I come in here, though, and I create my own constructor, even though this guy takes a bunch of arguments, Java now says, you got this. You must know what you're doing. I'm not going to give you a default constructor because you obviously need to do something more than that. So since you wrote your own constructor here, that's the dude you're going to get, and I'm not going to give you a default one. Therefore, it's now not happy with that. Make sense? And if I take that line out, it's not happy because invisibly here, it's trying to call that parent's default constructor. So what's Java saying? It's saying, look, possibly an object-oriented design pattern that we might say. Let me open this up here. This is more about the goals of an object-oriented language. Limit the well, here, let's write it a different way. Do not write the same code more than once. All right, so object-oriented languages have this idea called encapsulation. Encapsulation, which is a fancy way of saying create containers for hiding our wires, using our telephone example, right? So we create a class, we stuff all the details in that class, and now we've encapsulated those details inside of that class. That's an organizational tool, just with a scary-ish sounding word associated with it. Who cares? Okay? So because of this, Java and other object-oriented languages, this isn't a Java thing, this is an object-oriented thing, wants to encourage us to abstract our solutions to problems, simplify our solutions to problems by saying, okay, this is something that more than one thing is going to need. So we're going to write it in this class, and then we're going to let these guys leverage that thing that we've already written, rather than writing the same logic more than one time again. So Java wants to encourage us not to do this type of thing, because we've already written that code in our parent. We're doing that setup already. So don't rewrite code that you've already written once. Now, why is that a good idea? Why is that good practice not to write something twice when you've already written it once? Other than just wasting our time. There's got to be another side effect to it. Okay. Confusing how?
If you are changing it in one place.
If you change it in one place, and you might forget to change it in the other. So if you have the same stuff written in, just we can keep it simple and just say in two places, and you change the way this guy's implemented, you now have to remember to change the way this guy's implemented. If this guy calls upon this code, you only have to change it in that one place. Make sense? One point of failure is better. Okay, so kind of keep that in mind. Because sometimes, and this is going to happen probably often when you're a programmer, especially when you get out into the workforce, because now you're kind of, when you're a professional developer, you're kind of juggling two different things. There's the idea of writing, well-written, easy-to-read code, kind of written the correct way, or in a reasonable way, a way that you can argue that this makes sense the way I wrote it this way. So think about kind of our simple objects here with like a person. We originally had all these guys as private, right? And when something's private, what does that mean? Okay, only be accessed directly from within that class. Now, what if we need access to it outside of that class? We might need a person's first name or last name or age. Those are things we might need, right? So what do we need to do? If we make a variable private and we want to have access to it, read-only access outside of the class, what do we have to do? Write a getter. Give ourselves a function, a public function, that will return the value of a private member. And the advantage of that, it gives us read-only access. Won't let us change it, right? Just says, hey, here's the first name. If you need to use the first name, I can give it to you. I'm not going to let you change it. So that's going to require a setter, or historically a mutator is what they were called. Now, is creating a private variable and then writing another function for a getter a couple of extra steps? I mean, if we're only doing it for one variable, not a big deal. But let's say you have an object that has 50 variables in it. Something like that. And let's roll back the clock a little bit before we had the right click and generate getters and setters. Might have been a little bit inconvenient to make a variable private. Yeah, it might have taken some extra time. You might have spent 20 minutes kind of writing some tedious, frivolous code, when maybe you were only going to use that object in one or two places. And maybe you were the only one who was going to use that object. So did you really need to be all that careful? I mean, why do we make things private in the first place? What's the rationale between making something, when we choose to make something private, besides me telling you, always make something as private as possible, then loosen the reins as you need it. So besides me just saying, just do it that way, why is that rationale even in existence? What's the advantage of making something private? Kind of just said it in this last example.
Protects you against changing it in the wrong place.
Yeah, gives us the ability to govern changes, to police changes. Now, giving us a getter, that's just giving us access to the variable. Read-only access. Like, you want to know what their first name is, that's fine. Okay, but we're not going to let you change their first name. That makes sense? If you have a variable set as public, now you can get that value, but you can also change that value. So we would typically make something private for most of the reason is going to be because we want to control who's allowed to change it and what they're allowed to change it to. Right? Maybe you have an age and somebody has to, and you want to make sure that if somebody's allowed to change the age, that they're not changing it to a value that's less than or equal to 0. Something like that. Or they're not changing it to a value that's less than 0. I guess, does anybody actually say somebody is 0? You always use the number of months then, right? Weeks? You start with weeks and then months? 6 weeks old? He's 14. Was there some funny movie not that long ago where, they had like a 6-year-old or an 8-year-old or something like that? Yeah.
The 4-year-old is they're asking, oh, he's still in diapers?
Yeah, he's 78 months or something. I think it was older than that. Whatever it was, it was some ridiculous number, like it's like, how old's the little guy? Oh, he's 78 months. Funny. See, that was before Movie Pass days, and I learned all that from the trailer. I wasn't gonna pay to see that movie. Now I don't pay, and I go see My Little Pony. All right, so we make stuff private because we want to limit who can change it, right? But what if we're the only ones who are going to be using that object? What if we needed kind of a quick object to store 5 or 6 different pieces of information rather than having 5 or 6 individual variables? And we just slap together a quick class, throw 5 or 6 variables in there, make them all public just so we had convenient access to it. Could we make an argument that that's okay? If we're the only ones who are going to be changing it, and we're not controlling, trajectories of rockets and stuff like that with this, is that the end of the world? I mean, we can make the argument that, well, technically it's not proper programming. It's not, perfect programming. But, if you're making the decision, you're making an informed decision. Like, you chose to make them public for convenience rather than because you didn't know any better. Those are different, right? And you might save 20 minutes of work. You might save your boss 20 minutes of paying you. Now, at some point you might not care about that, but if you get some job loyalty or something like that, you might want to do the best job you can. You might say, look, I'm not really gaining anything by making these private and giving myself getters. I'm going to make them public so I can get this done quickly and accurately. And I'm doing this for a targeted reason because I know that I chose to do it this way, not because I didn't know any better. Does that kind of make sense? You're going to end up having your own programming style. So sometimes you'll make decisions like this that maybe go against a little bit of that idea of what's perfect or proper programming. But when you're doing it for an informed reason, you're probably fine. Okay? If you're on the job and you're doing a lot of trial and error stuff to see if something works, probably need to brush up on your programming. Okay, if you're writing stuff and you're just slapping stuff on the page and compiling it and hoping it works, that's not the way you want to. That's not the way you want your career to unfold. Okay, that's why as students we practice this stuff. Okay, so Java wants to encourage us to not rewrite this code more than once. For the reason of just convenience, right? You already wrote it once, why just call what you already wrote? Secondarily, as she pointed out, if you break it in one place, if you change it in one place, you broke it in another place if you didn't remember to change it. So rely on a single point of failure if you can. Okay? So for our patient, we will use our parent, who is person, to do the initial heavy lifting. Then we will differentiate ourselves by setting the balance up. All right. Now we're going to say, and what I had done last time is I said that this guy actually does not implement comparable because person is not what's comparable here. It's patients that are comparable. Make sense? So we're going to do that. We're going to get rid of our compare to. Then we're going to come in here. We're going to say that this guy is the guy that actually implements comparable for comparing patients to each other. This guy now is telling you, hey, look, you've advertised you're implementing comparable. You better write the function that you have to write for that guy. And that's the compare to function. So we'll write the public int compare to, and this guy is going to take in a patient as a parameter. Now, how did we know that this function had to look this way? Did I just memorize that?
Break it down. Except for the name.
Okay, well, first thing, you could have hovered over this when it was screaming at us. We probably could have gone to the documentation. And do I actually have Java documentation open here somewhere? I don't. So I'm just going to do a search for comparable. Well, that's actually a word. So let's do comparable Java. So here's our interface for comparable. All right. Now this format here, I don't remember if I told you what that format's called. Anybody remember what that's called? Did I tell you what it's called? Does anybody happen to know from previous knowledge or anything? Compare to that's related to the comparable. I'm talking about just this piece right here. Just this piece right here with the angle brackets and the generic T is in there.
In C# we use as a component
Use the same thing. It means the same thing in C#. I'm asking what is this thing called? What's the idea of this called? Like the idea of what we've done here when we use extends, this is inheritance. That's the idea of inheritance. Okay, so what's this the idea of? You've seen it in C# with Unity, right? But we've never actually given a name to it, right? Okay, this is something called generics. All right, so generics is used in most of our modern languages. Java, C#, it's heavily used in there. And it actually solves an interesting problem. And it's a problem we'll kind of come back to. We'll talk about in more detail next semester in 300 when we're talking about data structures. But generics, the syntax is typically, so at least in Java, the syntax is some class name T. And so, so if I use a real life example here, this will be a linked list thing, or from a 300 thing, so we'll call it linked list. So if I have a linked list of type T versus a generic linked list. So if I in Java say linked list LL is equal to a new linked list, think of linked list kind of like arrays. I'll differentiate them next semester. Don't worry about that. Pretend like you're not even seeing this, for example. Okay? This guy is capable of holding generic objects. When I remove a value from a linked list, it will come out as a generic object, even if it went in as something else, like a string maybe. Okay, and we've seen this before. So when we use in Android, when we say this dot find view by ID, and we're asking for like an edit text, the name of an edit text, it comes out as a generic view. Because the get view by ID, whatever the construct is, whatever that container is that holds all of our views, it gives them to us generically as a view. And then we have to say, I knew he was an edit text, so I'm going to go ahead and cast him to edit text. So maybe that's actually the better example for us since we've seen that. So when I say this dot find view by ID, and I give this, some ID, what comes out of here is a generic object that we have to then cast into something like an edit text to turn it into what it actually was, because we knew what it actually was. That make sense? So what we can do with these things called generics is we can say, look, I'm going to hold a collection of stuff. Now, the default version of this is just the stuff is going to be objects, because we know that everything is an object. All right, so if I go to Target and I buy buy a container that knows how to hold stuff, I could throw anything I want in there, right? I can throw shoes, I can throw sunglasses, whatever I want. I can put whatever I want in there because it's made for holding generic stuff. But if I go to Target and I happen to buy a container that was specifically built for holding shoes, as if those specifically existed, but now all of a sudden I'm not allowed to put other things in there. And because I'm not allowed to put other things in there, when I take things out, it will automatically give them to me as a shoe, not as a generic object. So if I create a linked list of, for example, strings, and this guy's a new linked list of string, like that. When I put stuff in, it's going to expect me to pass it a string. When I get stuff out, it's going to give it to me as a string. So I just bought a container, well, I built a container, that can only hold one kind of thing. Make sense? So when I get things out of that container, it's going to give me them as that one kind of thing. I won't have to cast it back to whatever the thing actually is. So generics helps us in situations like that where we want to explicitly say what kind of value we're holding in a collection so that it'll expect the right kind of value, and really more conveniently for us, it'll give us the right kind of value. Okay, so that's the idea of generics. We're not writing them in here. I won't ask you about it on the test, but this is, it's an important thing, and it's used in modern programming, and we'll use it quite a bit next semester. And I think I've mentioned it before. Well, first of all, how many of you are signed up for 300 next semester? Most of you should be. All right, so if you are a IT major, 300 is not required. I'd still strongly encourage you to take it. It's going to benefit you in your later classes, and it'll benefit you in industry. So if you have room for it in your schedule, I would take it. Similarly, we're also going to have Game Programming 2 offered next semester. So if you took Game Programming 1 this semester, or if you've had some experience with Unity, you can talk to me. I'll be getting the CRN for it here pretty soon. It'll probably be offered at that same time, the Tuesday, Thursday, 8:05 a.m. class, but you can do it online if you can't attend the class directly. But in any case, I'll have the CRN for that shortly. I had to have the registrar add it to the schedule. But 300 is a class that would benefit both majors. If we had our druthers, we would get it as a required course in IT, but there's only so many courses that we can require. So I encourage you to take it if you have room in your schedule. Okay, and that's the continuation of this class. We just keep going with more stuff. So that's generics. That's what that syntax means. If I want to take that one step further, actually, let's say that I created a linked list capable of holding persons. The persons that we implemented. What could I put in there? Or patients, because patients are persons. Make sense? So this could be a container built for holding shoes. Could I put basketball shoes in there? Because a basketball shoe is a shoe. But what do we have a generic shoe, which is something that goes onto your foot. A basketball shoe is what? Usually kind of a high top, maybe a certain kind of rubber or material on the bottom that's grippy on hardwood floor, where a soccer cleat is going to be built differently than a basketball shoe, but they're both shoes. Make sense? So same thing kind of exists here. Okay, so we'll have our patient, which is going to utilize our parents constructor, then differentiate themselves. We're going to compare ourselves to patient. Oh, and I was showing you in the documentation here, the comparable interface. So if we wanted to know what this meant, when we come down here, it tells us, here's the method that we have to write for this guy. If we want to implement an interface, because an interface does not imply an implementation. An interface applies rules, a structure you have to follow. Okay? We're in charge of implementing something. We just happen to implement something specifically called this. So this tells us what we have to write. Here's the method detail. It tells us how it should work. Okay, so it tells us that it should give you a value less than 0 if blah, blah, blah. All right, so we're doing this on balance. So we're going to compare one patient to another patient. So we'll say return this dot balance minus p dot balance. Now, this is going to give us that value as a float because the balance is, well, as a double because the balance is a double. But now we have an issue. So let's say that, and we want the smallest balance to, it should be true if one balance is smaller than the other. If the balance of this guy is smaller than the balance of the guy we're calling in. But what if my balance is $13.18 and the guy we're comparing ourselves to, his balance is $13.22. Who has the lower balance? I do, right? 13.18 is smaller than 13.22. By how much? 4 cents. That's a double. What happens if I convert that to an int? So if I typecast that to an int, that guy becomes a 0. It does not round, right? Even if it did round, it would still be a 0. That's not what we want, because 13.18 and 13.22 are different numbers, right? So we can't be as fancy about this one. We're going to have to actually ask the questions. Or we can multiply it by 100. We could do 13.18 times 100 minus 13.22 times 100, and that would give us a number that would be big enough. But this would be a clearer way of writing it. Anyways, we could just ask the question, if this dot balance is less than p dot balance, return a -1. Else if this dot balance is greater than p dot balance, return a 1. Else they must be the same, return a 0. Make sense? All right, so this pretty much spells it out, how the compare to method must work. So now we know how to compare balances between patients. Well, really, now we know how to compare patients to each other, and we compare them in terms of their balances. So we'll go into our main activity now. And here's all of our patients. We told it to print out our patients, so we'll go ahead and do that first, and we'll see that the balance is in the current...
We're not actually calling compare.
No, arrays.sort uses the compare to. Arrays.sort, this guy right here, which we're not calling yet, we have commented out, he relies on the object we pass it to be a comparable. The array of objects we pass it to be an array of comparables. Things that have a compare to method and have advertised themselves as being comparable. They have to do that. That's the error checking part of it. If I pass it an array of persons, where persons currently do not implement comparable, it'll scream at me because it'll say, I only know how to sort comparable things. Even if we put a compare to inside of persons, without advertising it as implementing comparable, arrays.sort won't have any guarantee that it'll be able to call that function. If you advertise yourself as being comparable, arrays.sort can say, okay, because you're comparable, I know you're going to have a compare to function. And I can confidently call that function. Waiting for target device. Why is this taking so long? You
From
think? Try it again. I just updated this yesterday. Maybe that was the problem.
it's still on 2.3.
Hmm?
Still on 2.3 on the studio.
Am I? Well, I updated its own built-in update yesterday.
It's much better than 3.0.
Is it? Are you sure I'm in 2.3? No, I'm in 3.0. All right, so there should be our, well, wherever it is. I need to go to Logcat. So there's my patients in the original order that I had them in. So now if you pass it into arrays.sort, because it's comparable, it should put the balances in ascending order. So we'll do that. So because we've created these guys in such a way that they are now sortable, we can rely on our sort factory that comes with the arrays class. Now, this is a class method or an instance method? Class method, how do you know? Calling it with the name of the class in which it was presumably defined. We know this is a class because it's capital letter, probably a class. Say this again.
I thought we had to put in patient. Array that sort patient.
Well, my arrays is called persons.
Oh, okay.
Yeah, the array. I mean, it might be a bad variable name for my array, but that's what we called it. So I'm telling him sort that array of stuff. This could have been called elephant. So there's my patient sorted by balance. Make sense? Okay. Now, in real life, and let me do this. Well, for no other reason than to support this example, I'm going to create a person. P is equal to a new person. And this guy's going to take in a first name. So I'll take in Mike. That's interesting. Littman. Age is, how old did I say I was? 18? And gender. Yeah, very interesting placeholder format for that kind of shows us what those are. Many new programming languages actually, see, Swift does not do this. Swift went away from this. Objective-C takes parameters that look similar to this, where you actually write it in there like that, so you know exactly what those four values are here. And let me give you an alternative example. So let's say I had something called science value. SV is a new science value. 2.38, 11.1, 13.0, something like that. Okay, assuming I had a class like that, when we look at it this way, do we necessarily have any idea what those three values represent? We don't know what they represent. We have to go and look at the constructor for science value and look at what he was expecting to know what those values represent. Some languages would have a format that looks similar to what this is up. This is more of a something called Syntactic Sugar. It's just a visual helper for us. But it would have something, maybe this is the X, this is the Y, this is the Z, something like that. So now we've given some semantics, some meaning to those individual parameters that we can see right here. That could be beneficial for making our code readable, right? But languages, C++ didn't have that, therefore Java didn't, therefore C# didn't. Objective-C was on the other side of things, so Objective-C was actually very verbose to like the extreme for this type of thing. And then Swift kind of went back in the direction of a Java C# type thing. So not the end of the world, but that's what this is kind of a nice benefit thing they put in here. Okay. So if we think about this in terms of real life, there are definitely patients in real life, right? There are definitely persons in real life who have a balance and maybe have a doctor name and stuff like that. We can elaborate on what our patients are. But in real life, does it make sense for there to be a generic human, generic person? All of us are students, right? Okay, so you have all the stuff persons have, but then you have a GPA, you have a class schedule, and stuff like that, right? There's things that elaborate on your base beyond being just a person. Is there a such thing as somebody on this planet that is just a generic person? They have no other attributes beyond that, nothing else that makes them special? Everybody at some level is kind of a citizen of a certain country, right? And that gives them, a country of origin or something like that. So really the idea of a generic person isn't a thing. Like that would almost be like if you called somebody like meaningless. You're so generic. You're just a person. Nothing more than that. It's like a slight against them. That's a bad thing to say about them. So in reality, we probably wouldn't be able to create persons. Persons are important. They act as a building block for our inherited objects. Creating a generic person helped us in creating a patient. So inside the patient class, we only had to focus on the things that made them different, right? But we would probably never do something like this directly. We would never create a plain Jane person. Now, Java has a flag that we can put in front of a class. So I can go to person here and I can say, you know what? Person is a public abstract class. Public abstract class. So now if I come back over here to main activity, notice Java is no longer a fan. Okay, all I did was make person abstract. Now, what abstract does, this means we cannot create an instance of this class. I'm going to say directly because an instance is still technically being created when we create an instance of patient, because a patient is a person. But we can't directly create an instance of abstract classes. It's not allowed. All right. So why would abstract classes even exist? What's the purpose of them? Does it make sense for us to have written the person class as a helper for building the patient class?
Because you might have to put someone else
Yeah, so we could certainly then have maybe a class for doctor. We can have another class for like soccer player. You know, we could have classes that add additional meaning to persons, but they all rely on that core functionality of a person. Even though we've said that it doesn't actually make sense for a generic person to ever exist. Therefore, we would never create an instance of generic person. Instead, we'd use this as a starting point for a patient, or a starting point for a doctor, or for a soccer player, or for an astronaut, whatever it is, right? So abstract is useful for supporting the inheritance model such that it prevents us from directly creating instances of objects that only exist as a building block that were never intended to exist on their own. Make sense? So again, this is a self-policing type thing. We can make a class abstract. You know, we're all good with the idea of why a person might exist, a person class, because we can quickly imagine that we have all sorts of different persons in this world, but they each have kind of specializations beyond that generic person. But at the same time, did we have to put abstract in front of it? Or could we have just told ourselves, I'm never going to create an instance of person? We didn't have to throw abstract on there, right? You know, you didn't have to throw abstract in there, but you had to. You didn't have to throw abstract in there, but you had to respect the fact that you weren't going to create your own instance of person. Does that make sense? Whereas if you put abstract on there, you were specifically almost self-policing yourself. Maybe this is a thing where if you come back to this code in 6 months and you try to create an instance of person because you think that's the guy you're supposed to create an instance of, if you put abstract in front of you, Java will scream at you and say, hey, when you wrote this, you never intended to be able to create an instance of this guy. Give you a little squiggly red underline and say, you know, this isn't an instantiable thing. That make sense? Okay, so abstract's important tool. Probably for your programming life, it's going to be more important for you reading other people's code or for you using existing APIs or somebody else's existing library, code library. Because if you see a class that's defined as abstract, right off the bat, you should know, I cannot create an instance of that guy. Make sense? Questions, comments, concerns, bribes? All right, so next class we will come back. We'll talk about the final exam, and we will wrap up the last couple of topics for this course. No homework for Thursday. We're not at a stopping point for a homework assignment anyways. And like I said, if you are not currently enrolled in 300 and you have room in your schedule for next semester, I strongly encourage you to do that. And also be on the lookout for the Game Programming 2 class, which I'll have a CRN up on Slack shortly. Hopefully by the end of the week.